All right, everybody. We're going to start day 2. So today we're going to talk about mostly word problems. In the middle there, we're going to do another method. Yesterday we talked about graphing and elimination. Today we'll talk about substitution, which is easier sometimes. Most of today is going to be focused on those application problems. And we're actually going to start with an application problem. So a school sells t-shirts every year as a fundraiser. The first year, short sleeve shirts cost $5 each and long sleeve cost $7 each. They paid a total of $2,500 for the shirts the first year. The second year, they bought the same number of each type of shirt, but the company raised the price. Bummer. They raised it to $8 for short sleeves and $12 for long sleeve. Now the school spent a total of $4,200 on shirts the second year. Now, assuming they bought the same number of shirts, which notice it says they did, and that's super important. They bought the same number of shirts each year, right? How many of each type of shirt did the school buy the 2 years? So if they bought 50 the first year, they bought 50 the second year, right? If they bought 30 the first year, they bought 30 the second year. They bought the same number each year, and that's what's going to help us write these equations. If it wasn't for that, we couldn't really solve this. So, just like yesterday, you want to figure out, all right, what are the two situations we're dealing with here? And here it's pretty clear. It's first year and the second year. And so these are the two equations we're going to need to write. So the first year, each short sleeve shirt cost $5. So we'll have 5S, and that S will be for the short sleeve. And each long sleeve shirt costs $7, so plus 7L, and that L will be for the long sleeve. And what did they spend a total of? Well, they spent a total of $2,500 that first year. Second year, pretty similar, right? They bought the same number of shirts, so we can still use that variable S for the short sleeve shirts. So the second year, they spent $8 for the short sleeve shirts. They spent $12 for the long sleeve shirts, right? We want to figure out the total, so we're going to add those two up. And it was $4,200 was the total for that second year. All right, then from here, I want you guys to solve this using elimination, so that method you did yesterday. So pause the video right around here. All right, if you haven't solved that yet, make sure you pause and solve it. Otherwise, let's look at how I did this. So start with the two equations, remember, multiplied by those leading coefficients, making sure we switch one of the signs. So I made it -8 instead of +8 for that first equation. Again, remember, if you have -5, +8, you'll get the same final answer. Your work will just look a little bit different. So when I multiplied those out, I got these two equations. Notice the 40s and the -40s, right? They're opposites. So when we add them up, those s's will eliminate. And we'll have 4L equals 1,000. We just solve that to figure out L. So L is 250. Now, if it just asked for how many long sleeve shirts, we could actually be done here, right? Because we know how many long sleeve shirts, 250 long sleeve shirts. But it asked for each type, so we got to figure out S still. So we plug that L back into one of the equations. I chose that first equation, but you could use the other one and get you the same answer. So I plug that in, solve for S. Yeah, S is 150. And then, since this is an application problem, we got to make sure we have units on our answers here. So our final answer would be 250 long sleeve shirts and 150 short sleeve shirts. So there, we used that elimination method to figure out how many of each type of shirt they bought. All right, so for this one, elimination was definitely the best way to go. But with some word problems we used, another method might actually be faster. And that other method we might want to use is called substitution. And really, when you're going to want to use this is when you have a variable that doesn't have a coefficient, or whose coefficient is 1, right? If you have that, substitution is a good method to use because it's really easy to get that variable alone. And that is actually our first step. You want to get a variable alone in one of the equations. So since that x, right, is already almost alone, let's get that x alone. And all we have to do that is subtract 3y from both sides. So we'll have x equals 3 minus 3y. Once you have that variable alone, then you want to substitute that into the other equation. So if we look at our, oops, let me scroll back up just a little bit. If we look at our other equation, we have 2x plus 5y equals -5, right? We're going to replace that x with this 3 minus 3y. So this is a lot like what we did with function notation, where we plugged an expression in for a variable. So we're going to rewrite this equation up here, but instead of 2x, we're going to have 2 times 3 minus 3y plus 5y equals -5. Right? So we substituted this thing right here in for that x, right? So it became 2 times 3 minus 3y plus 5y equals -5. And then from there, you just solve for that variable. So we would solve for y, right? Now that y is the only variable, so we'd have to distribute. So we'd have 6 minus 6y plus 5y equals -5. Combine our like terms, we get -1y there. Oh, still have that 6 minus 5. Subtract that 6, so -1y equals -11, or y equals 11. So we know what y equals, right? But again, a solution is a what? That's right. It's a point, a point, a point. So we know y. Now we got to find x. Now, step 4 is to find x. Now, this says plug back into either original equation to find the other variable. That's true, right? That will work. There's actually an easier way to do it. If we plug it back into that equation from step, I believe it was step 1. Yep, step 1. If we do that, the x is already alone. So it's going to be really easy to figure out x. So I'm going to plug it back into this equation up here. So instead of x equals 3 minus 3y, we have 3 minus 3 times 11. Notice the x is already alone, so all we have to do is simplify this. That's 3 minus 33, or -30. So we know our x, we know our y. Last thing we got to do is just make sure we write it as a, you guessed it, a point, a point, a point, a point. Always write it as a point. So it would be the point -30, 11. -30, 11 there. So again, just a quick recap of what we did. We got a variable alone, plugged it into the other equation, solved for y, plugged that back in to find our x. Great, so I'm going to have you guys try one of these. So here it is, example 10. So use substitution to solve this. Again, I want you to pause the video and try it right about now. All right, if you haven't paused yet and try it, make sure you do that. Otherwise, let's go over what I did here. So I had to get a variable alone, and remember, you want to find one that's easiest to get alone. So in this case, that x in that first equation would be the easiest to get alone. So I subtracted 5y from both sides and got -9 minus 5y. Then we take this thing, let me get my highlighter right, we take this thing right here and we plug it into the x in the other equation. So instead of 4x plus 3y equals -2, we now have 4 times -9 minus 5y plus 3y equals -2. Now that it's only one variable, we can solve that. So to solve that, I distributed, I combined like terms, added 36 to both sides, and got the y alone. So we got y equals -2. But we are not done because the answer is a point. Don't forget it's a point. I'm going to keep saying point, point, point. Don't forget point. Right? So we have the y value. We plug it in to that equation with the x alone, right, to find the x value. You could have used the other equation. You'd still get you the same answer. This is just easier. And we got x is 1. So our final answer is the point, 1, -2. 1, -2. So at this point, we have 3 different ways to solve these. We have graphing, we have elimination, we have substitution. So I don't care which one you use. right? I don't care which method you use. I want you to do whatever is easiest and fastest for you in that situation. In some cases, it's easier to use elimination, some it's easier to use substitution, some it's easier to use graphing. You got to be able to figure out which one is which and why. So if we look at this first one, A, let's think, okay, would this be easy to plug into my calculator? Well, it's in standard form, right? Both of these are in standard form. Both of these are ax plus by equals c. And if you remember from yesterday, if we have that and we want to use our calculator, we got to convert it. So calculator is out of the question, right? That would take too long. All right, let's think about the one we just learned, substitution. All right, are there any variables that would be easy to get alone? Well, they all have coefficients, right? This one is a 4, 2, 3, -6. So you could get them alone, but again, it's going to take some work. You're going to have to do some converting. Not super easy. So in this case, right, graphing is not going to be easy. Substitution is not going to be easy. Let's use elimination, right? Elimination would be to use this one here. We would just multiply both equations. First one by 3, second one -4, right? So there you're going to use elimination. All right, how about B? Well, again, standard form, so we're not going to want to do graphing. Is there anything that we could get alone easily? Oh, yeah, look at that x. That'd be real easy to get alone. All we'd have to do is subtract 2y from both sides. We got x equals 8 minus 2y. And then substitution is going to be pretty easy. So here, I'd use that method we just learned, that's substitution. And finally, C, right? They're both in slope-intercept form. Your calculator takes that. Just graph on the calculator, right? That's nice, that's quick. Your calculator tells you the points. So using that calculator in that case will probably be the fastest method. Now, any of the methods will work for any of these, right? But there are going to be some that work easier with certain problems. And the more you practice, the better you're going to get at seeing what works better when. All right, so to finish this off, we're just going to do 3 word problems together, and then I will let you guys work on practice 2 for your homework tonight. So these word problems, we look at example 11. It says a pizza shop is experimenting with their slice sizes. The first week they're open, they cut their small pizzas into 4 slices, their large pizzas into 6 slices, and sell a total of 1,100 slices of pizza. The second week, they make the same number of large and small pizzas. That's very important. But cut small pizzas into 12 slices and large into 15. If they sell a total of 2,910 slices the second week, how many of each type of pizza did they make? All right, so first we got to figure out what are the 2 situations here. In this case, our 2 situations are the 2 different weeks. We got week 1 and we got week 2. Right? So we're going to have to write an equation for each of these. So I want you to take a minute, try to write those equations. So pause the video here and then write those equations. All right, so this is what we should have for week 1, 4s plus 6l equals 1,100. Week 2, 12s plus 15l equals 2,910. And in this case, right, S stands for the number of small pizzas they made. Notice it's not the number of small slices, but actually the number of small pizzas, right? Because those 4 and 12, those are the slices. The S stands for the number of pizzas they're slicing. And same thing with L. L is going to stand for the number of large pizzas. All right, then we're going to solve this thing. In this case, right, nothing easy to get alone. It's not in slope-intercept form. So let's use that elimination method. So again, I want you to pause the video and solve this using elimination. All right, if you haven't solved that yet, make sure you solve that. And let's walk through. I actually did this one a little bit different, and I'm going to show you what I did here. So if you solved using that elimination method, right, and doing it the way we had talked about in the last video, you'll still get the same answer. But I want us to see a little shortcut we can actually do with this problem in elimination. So I had our 2 equations, and I noticed, I said, hey, I could multiply the top one by 12 and the bottom one by 4, right, and switch one of those signs. Then I'm going to have really big numbers. But I noticed if I multiply that first equation by -3, well, then my first variable, my first coefficient is going to become -12. right? And that's an opposite, so those will still eliminate. So in this case, all I did was multiply that first equation by -3, and I got this -12s minus 18L equals -3,300. And then because these are opposites, right, I didn't have to multiply that second one, right? I could just do that and then add these two equations, right? And those will eliminate. So that's what I did. I added those two equations. The S is eliminated, and I was left with -3L equals -390, right? So probably a lot smaller numbers than you guys were dealing with than if you did the 4 and the 12. But I'll still end up with the same L value, which was 130. And so just a little shortcut there. Then, once I have that, again, plug that L into one of the original equations. So I think I chose the one from week 1, because it was smaller numbers, and I'd figure out, solve for S, figure out S is 80, so there would be 130 large pizzas and 80 small pizzas made both weeks, right? They made the same amount each week. All right, then let's look at another example. So a band is selling posters of a record, posters and records at a concert. It costs them $3 to make a poster. They sell them for $7. It costs them $10 to make a record. They sell for $20. If they spent $145 to make posters and records and made $305 in sales, how many posters and records did they sell? So here the two situations aren't as obvious, right? The situations aren't as clear. It's not like a week 1 and week 2. Or what was that first problem we did again? It wasn't like the, year 1 or year 2. Here the two different situations are the amount they spent and the amount they sell. So our two situations are going to be for the cost of making it, right? And the second equation is going to be for the amount they sell, or a fancy word for that is the revenue, the amount of money they brought in, the revenue. So our first equation, let's think about it, is that it cost them $3 to make a poster. So they paid $3 for every poster, P equals poster, right? And then it cost them $10 to make every record. So R will be record. We'll do 10 times R, the number of records they made. And they spent, the cost to them was a total of $145. So this is our first equation. Our second equation is going to be about the amount of money they bring in. So for the posters, they make $7 for every poster. They make $20 for every record. And they made a total of $305. So here, our two equations again are the cost and the revenue. All right, pause the video, give this one a try. Solve this guy out. All right, so if you haven't solved it yet, make sure you pause and solve. Otherwise, let's go over this. So what did we do here? We used elimination, so we multiplied the top one by 7, bottom one by -3. I guess here you could have done a little shortcut, right, and multiply the top one by -2, and these r's would have canceled out. But you'll get the same answer if you do it this way, and I'm imagining this is the way most of us did it. Let's get rid of that. Bye. So when we do that, we'd end up with these two equations. That's a -915. I know it looks a little funny there, but that's what that is. We add them up. Those p's will eliminate because they're opposites. So we have 10r equals 100. So r equals 10. Got to plug that in to find p. So plug it in. I plugged it into the first equation because, again, smaller numbers. I like the smaller numbers. Solve for p, and we get p equals 15. So what did this band do? This band sold 10 records and 15 posters. 10 records and 15 posters. All right, we're going to go over one last problem on this video, and I'm not going to lie, this is the one that people always get caught up on. So if you have to go back and rewatch this, right, that's fine, but make sure you get this. So, example 13, an airplane's distance is affected by wind speed. Flying with the wind, a plane flew 1,000 miles in 5 hours. Flying against the wind, a plane could only fly 500 miles in the same amount of time. Find the speed of a plane in calm air and the speed of the wind. So here, the two things we got to find are the plane speed, if it was just in calm air, right? And the wind speed, speed of wind. All right, so the two situations we're dealing with here are we're dealing with the plane flying with the wind. So the wind is going the same direction as the plane, and against the wind. So this is where the wind is pushing back on the plane. So I'm going to show you a little video to help us think about what's happening here. So if we go to YouTube. All right, so this video demonstrates really both situations really well. At first, it's going to show what it would be like walking with the wind, and then I'll show what it would be like walking against the wind. So notice when the baby's going with the moving sidewalk, it was moving faster, right? And if it stops, it's still moving because the sidewalk's going. Then as it's going in the opposite direction of that moving sidewalk, right? Even though it's walking, it's not moving. If it wants to actually make up some speed, right, it's got to go faster than that moving sidewalk. So if it wants to make up the distance and get to that Starbucks, it's got to go faster than the sidewalk, right? And that's hard because it's got itty bitty legs. But so close, and then it fell. So this video sort of shows what we need to see for this, right? With the wind, so when I was walking with the moving sidewalk, think about it. The baby was going faster, so it helped the baby move. So with the wind, right, the baby's sort of speed, or I guess in this case, the plane speed is the speed of the plane plus the speed of the wind, right? The wind is going to help when it's moving with it, just like when the baby was walking with the sidewalk, it made it go faster. So this is the speed with the wind. Against the wind, right? Think about the wind hurts the plane. It slows it down, just like the moving sidewalk slowed down the baby. So it would be the plane speed minus the wind to get sort of the overall speed. And then we're going to use that formula we've used a couple of times, that distance equals speed times time. So right, we already have the speed. So then with the wind, how long did it take? Well, it went 5 hours. And how far did it get? It got 1,000 miles. Against the wind, how long did it go? Well, it went the same amount of time. So that's also 5 hours, but this time its distance is only 500. So here for both of them, right, we had our speed times time equals distance. Our speed times time equals distance. Now, this isn't in standard form or slope-intercept. So first thing we're going to want to do is get this into standard form, both of these. So if we distribute that 5 for the with the wind, we'll get 5p plus 5w equals 1,000. If we distribute for with against the wind, we'll get 5p minus 5w equals 500. And notice here, elimination is going to be really easy. We actually don't even need to multiply by anything because these w's are already opposites, right? If we add those up, 10p, the w's are going to eliminate, equals 1,500. And then if we solve for p, the p would be 150. So we know the plane speed now would be 150 miles per hour. And we just got to figure out the wind speed, so we plug that 150 back into one of our equations. Doesn't have to be one of the original ones, right? We could go to one of the ones we did over here, so I'm probably actually going to use this one. So we'll have, too far, 5p, but instead of p, we got, 150, so 5 times 150 plus 5w equals 1,000. All right, then if we solve that out, 5 times 150, what's that going to give us? That's going to give us 750 plus 5w equals 1,000. Solve for that w, so 5w equals 250, or W equals 50. And so in this case, that means this wind is moving 50 miles per hour. So the plane, for our final answer, we'll say the plane had a speed of 150, and the wind had a speed of 50 miles per hour. Great. All right, so this is actually the last video. You're not going to watch another video tomorrow. What you're going to do is take the practice quiz. So when we come back, or when I come back, what we're going to do is that first day we're going to sort of review all this material together, and the next day we're actually going to take that quiz. So tomorrow what I want you guys to do is sort of take a practice quiz. See how well do you know this stuff if you're not watching the video, right? And by that I mean like watching the video at the same time. But otherwise, that is the end of this video. Thanks for watching this. Make sure to comment, like, and subscribe. Oh yeah, just know that's what all the YouTube people say. Otherwise, have a good rest of your day, make good choices, and I will see you when I get back.